A very good morning to everyone. On behalf of the Women Chemist Committee of the Institute of Chemists, Ceylon, it gives me great pleasure to welcome you all to the Sri Lankan Women Chemist Breakfast, which is held for the second consecutive year. To commence the event, I would like to invite Professor Sriyanti Dharanegala, President, Institute of Chemistry, Ceylon, to deliver the welcome speech. Over to you, Madam.
A very good morning to all of you. As President of the Institute of Chemistry, Ceylon, I warmly welcome all who are gathered physically and online to participate in the Sri Lanka Women Chemists Committee Breakfast event in keeping with the UPAC organized Global Women's Breakfast. As President of the Institute, let me give a brief introduction about the main activities of the Institute of Chemistry, Ceylon. The theme for this council year 2021-2022 is Shaping Minds to Breakthrough Frontiers in Chemical Research. The Institute of Chemistry has played a pivotal role in being the largest provider of graduate chemists to a vast array of organizations in the country. This has been largely due to the educational arm of the Institute of Chemistry, the College of Chemical Sciences, which administers the graduateship course in chemistry since 1979. A University Grants Commission accredited BSc program in chemical science has also got off the ground, commencing in 2020 with the second batch having been enrolled. The GIC has produced over 125 graduates per year, and the recipients have not only gained employment in private sector, but many have secured scholarships to universities in developed countries to pursue their higher studies, leading to a doctoral degree. The Diploma in Laboratory Technology, DLT, has also been very successful in providing the industry with technical personnel of high quality and in-depth knowledge. At the last convocation, which was held on the 30th of November 2021, the 38th batch of graduate chemists and the 46th batch of diplomates and in laboratory technology received their awards. The construction of the new building of the Institute of Chemistry at Malabe began in November. This new building will enable the College of Chemical Sciences to expand its educational activities further. The Institute also is involved in popularizing chemistry among school children as well as at the tertiary level. At the tertiary level, we have various activities, students interviewing eminent scientists, inter-university chemistry magic, inter-university debate, webinars by eminent scientists. At the secondary level of education, we have what is called the All-Island Inter-School Chemistry Quiz, Chemistry Olympiad, Royal Australian Chemistry Quiz. The Women Chemist Committee is also very actively involved in the Institute of Chemistry. This was introduced during the presidency of Professor Priyani Paranagama in 2019-20. In keeping with the Women's Chemists of the Federation of Commonwealth Science Societies, also known as Commonwealth Chemistry in some countries. Last year as well, we were able to participate in the International Global Breakfast meeting. As I said earlier, this year too, we are today participating with the annual event of Global Women Breakfast to coincide with the IUPAC Global Women's Breakfast. The Women Chemist Committee has organized 2 events to coincide with the Global Women Breakfast. The essay competition, in which undergraduate students are expected to write an essay about a woman scientist, and also an abstract in photo completion, where a research abstract is presented in one photo. The winners of this event will be announced today, and presentations will also be made at this forum. The prizes for these events will be at the annual sessions of the Institute of Chemistry to be held on the 22nd June 2022. Thank you very much all once again for your participation.
To commence the event, I would like to invite Professor Priyani Paranagama, Chairperson, Women Chemist Committee, for the introduction of the event.
Thank you. Good morning, President, Institute of Chemistry, Ceylon, Professor Sriyanti Dharanigala, all the council members, members of the Women Chemist Committee, all the postgraduate students, undergraduate students, research assistants, ladies and gentlemen. I'm happy to announce we celebrate Sri Lankan Women Chemist Breakfast event organized by the Women Chemist Committee of the Institute of Chemistry, Ceylon today. This event is organized in parallel to the Global Women Breakfast of the International Union and Union of Pure and Applied Chemistry, IUPAC. This is the second time the Women Chemist Committee of the Institute of Chemistry organized this event, the Sri Lankan Women Chemist Breakfast. The theme of this event this time is empowering early career chemists. Therefore, we have organized two events targeting our early career chemists. Our target groups were postgraduate students, undergraduate students, research assistants from academia and industry. They were encouraged to participate in this event to show their talents. So our first event was the photographic abstract competition. In this event, the clear instructions were given to all the applicants to prepare a photo that tells a story about their research. So the panel of judges selected 3 best photos, and they will be presented their story today. The second event was the essay competition on women in chemistry. So here participants participants were requested to write an essay on female chemists who has inspired them. So in this event, 5 best essays were selected by the panel of judges, and they are also given an opportunity to present the essay today. The best 3 essays are published in the our journal, Chemistry in Sri Lanka. So all the winners will be given certificates, gift pack at the annual session of Institute of Chemistry, which will be scheduled to be held on June 2022. I'm happy to announce we successfully completed both competition. All the winners are invited today to make their presentation. I congratulate all the winners, and I hope continue to celebrate this Global Women Breakfast next year with another exciting event too. And also I take this opportunity to thank all the members of the Women Chemist Committee, especially our President of the Institute of Chemistry, Professor Sriyanti Dharanigala, for giving us a wholehearted support to do this event, and also our 2 coordinators of the event, Professor Suranga Wickramarachchi who coordinate the photographic events, and Dr. Meda Gunaratna, she coordinates the essay competition. They are from Department of Chemistry, University of California, for their dedication, commitment to organize this event successfully. So I wish this a success. Thank you very much.
Thank you, madam. Moving on to our next step for today, we have invited the 3 finalists of the photographic abstract competition for the final round. To commence the session, I would like to invite Professor Suranga Vikramarachi, Coordinator, Photographic Abstract Competition.
The photograph tells the story you failed to put into words. For the first time, Women Chemist Committee called for photographic abstracts from the women researchers in Sri Lanka. We had a good response from our girls, and from all the submissions, we selected 3 finalists. And today they will be presenting their photographic abstracts in the women's breakfast. The first abstract is on guava leaf extract as a potential source of antioxidants, antibacterial, and photoprotective agents for sun protection cosmetics. It will be presented by Ms. D.H. Devade from University of California.
Do you like guava? Is it one of your favorite fruits? If not, then maybe its benefit will change your mind. Beside the numerous health benefits of guava, its leaves will be so good for your skin. Probably you didn't realize it. Skin cancer is the most commonly diagnosed cancer in the world, which is associated with exposure to the UV radiation. Therefore, the sunscreen formulations are widely used to prevent and minimize UV-induced photo damage. So the development of sunscreen formulations containing the plant-based photoprotective agents is recently being explored as they are considered to be safer than these synthetic agents. Therefore, my research was basically focused on the exploration of bioactive compounds of Psidium guajava, the common guava, leaves as a potential source of antioxidant, antimicrobial, and photoprotective agent for the sun protection cosmetic. How we did this? The chemical constituents of dried and powdered leaves of common guava were extracted into methanol by Soxhlet extraction method. The guava leaf extract was tested for antibacterial potential against 3 bacterial species such as Staphylococcus aureus, Escherichia coli, and Pseudomonas aeruginosa, the major potential pathogens in cosmetic, by using an agar well diffusion method. The highest antibacterial activity was detected against the Escherichia coli. The antioxidant property of this extract was determined by using the DPPH free radical scavenging assay, and it was found to be rich in phytochemicals with antioxidant with IC50 value of 148 microgram per milliliter. Finally, a UV visible spectrophotometric method was used to determine the sun protection factor to evaluate the UVB absorption capacity of the extract in the range of 280 to 320 nanometer. It shows an impressive sun protection factor with the SPF value of 34. According to the cosmetic standard, if a sunscreen product has a SPF value above 30, it is indicated as the high sunburn protection. The results of our study reveal that there is a potential of using guava leaf extract as a photoprotective additive for the sunscreen formulations. In addition, sunscreen supplemented with the guava leaf extract may have potential for minimizing the use of synthetic agent and reducing the production cost of sunscreen. The leaves of guava are where the magicals come from when you want to get a magical skin protection. Thank you.
Now I would like to invite Ms. M.T. M.K.M. Karunaratna from the University of Sri Jayawardenepura to present the abstract on enhancement of the photodegradability of natural rubber latex gloves through grafting of natural rubber with polystyrene or cinematic.
Morning, everyone. I'm going to present about the enhancement of the photodegradability of the natural rubber glove using polystyrene co-cinnamaldehyde. From the ancient time, there is no professional way to discard the glove in an environmental friendly manner. With the start of the COVID-19 pandemic situation, it became a more and more serious problem because there are tons of gloves dumped in the open area daily. As shown in image 1, if a glove dumped in this way, they accumulated in the environment for long term and it will lead to a lots of problem. Due to that reason, incineration recycling method had been tried earlier, but due to the drawbacks which came from this method, people find out a reliable another method to solve this problem. At the end, they find out degradation is the most suitable method. Among them also, photodegradation become a very handy method due to the renewable resource supply. Uh, in here, I have identified cinnamaldehyde as a natural photosynthesizer. It has aldehyde group. That means it could undergo the Norrish 1 and Norrish 2 reaction and make the radical. Those obtaining radical could attack the double bonds in the polyisoprene unit, and this phenomena lead to the degradation of the latex film. Here it was confirmed with both instrumental and visual method. This abstract indicate the visual method. According to the second image, I make a latex film by grafting the cinnamaldehyde. Here, styrene is used as a supportive molecule to get a better result. Here, copolymer has grafted to the natural rubber molecule using the sheet emulsion polymerization. Then the modified film and the normal natural rubber film were put in the environment, and after the T1 period, properties had evaluated. As shown in the figure, you could understood that modified film lost its own properties while natural rubber latex film remains the properties as its original state. Further zoom in the image, you could see that the initial there is some places the tech initiation happened. That means natural rubber latex film start the degradation. Further, cinnamaldehyde could be identified as a good antioxidant, which means it has a good antibacterial properties. In the earlier time, the degradable gloves was made using the starch light materials, but the problem is the storage time was limited. But this drawback is limited here due to the antibacterial properties. According to this cycle, you could see that by using the cinnamaldehyde, photodegradation of the natural rubber glove has enhanced. Finally, we could drive our world to this mentioned stage as shown in this image with the help of mentioned method. Thank you for listening. Have a nice day.
Thank you, Ms. Panaratna. The third presentation is on biodeterioration of polymer properties of polyethylene by endolipenic fungi. It will be presented by Ms. T.W.N.K. Pereira from University of Calendar.
Good morning, dear Sir, Madam. I'm Nipuni Pereira. Our research topic is biodeterioration of polymer properties of polythene by endolipenic fungi. As we know, the use of polythene in today's world is inevitable, and life without polythene is unimaginable. But accumulation of polythene leads to numerous environmental, economical, and ecological concerns. If we consider about the waste for the polythene waste management, biological treatments appear as a timely solution for the elimination of polythene from the contaminated environments. In this research, we explored the ability of fungi in deteriorating the polymer properties of polyethylene, and our candidate fungal species were endolipenic fungi. We performed these deterioration assays with 70 ELF cultures. Actively growing ELF cultures were obtained by inoculating them on potato destrose agar. PDA plugs of each ELF culture were inoculated into sterile mineral salt medium broth containing surface sterilized low-density polyethylene. After an incubation of 21 days for room temperature while agitating at 150 RPM, observations were taken. All determinations were performed as 4 replicates for each ELF. MSMB flowers with plain PDA plugs and sterile LDPE strips were used as the control. After completion of the incubation period, visual observations were taken and morphological changes were studied using scanning electron microscopic images. During the visual observations, untreated LDPE strips showed a compact structure without any cracks. In contrast, LDPE treated with ELF showed a partially broken face with many pores and sponge-like structures. By hand touching, it was felt a peeling nature in the treated strips. During the morphological observations using SEM, pits, cavities, several non-uniformly scattered vital areas, and surface roughness was clearly observed. These changes were not observed in the control strips. Moreover, fungal spores and mycelial attachment was detected in the treated strips, indicating the adherence and penetration of fungal hyphae into the LDPE. But further, biodegradation was analyzed based on the reductions in weights, tensile properties, increments in the degree of water absorption, changes in peaks of IR spectrum, water contact angle measurements, and GC product analysis. 10 ELF isolates out of 70 isolates tested showed signatures of biodeterioration. These results suggest that ELF could be used as an eco-friendly solution for treatment of LDPE waste. Thank you.
Thank you, madam. For the next activity, we have invited the 5 finalists of the essay competition to read their essays and to showcase their writing ability as a young woman chemist. To commence the session, I would like to invite Dr. Medha Gunarathan, Coordinator, Essay Competition. Over to you. Madam. Sorry, madam. You're muted.
Thank you, Shenali. This essay competition, Women in Chemistry, was organized to celebrate women chemists who have contributed to the field of chemical sciences over the centuries around the world. We received several essay submissions and selected the first 5 winners to present their essays at this event. So I will first invite our first presenter, Ms. A.L. Hettige from the Institute of Chemistry, Ceylon. Over to you.
We promptly associate the discovery of the structure of DNA with the names James D. Watson and Francis Crick, who won the Nobel Prize for one of the most important scientific accomplishments, the discovery of the structure of DNA. Yet someone who deserves equal recognition is none other than Rosalind Elsie Franklin. Born in an era where it was highly unusual to find a woman work at a science laboratory, Rosalind Franklin fought the battle of sexism in science and produced work that greatly helped revolutionize the path towards the advancement of science. Rosalind was known to perform exceptionally well in her studies. She won a university scholarship and graduated with a second-class honors after studying chemistry, and obtained her PhD in physical chemistry at the University of Cambridge. She did not stop there, as she knew that she was capable of much more. She joined King's College and set to work shining high-energy X-rays on wet crystals of DNA to figure out their structure. Yet her working environment wasn't an ideal one, as the academic culture during that time wasn't very keen on working with women and didn't believe females were as competent as males. There were constant disputes between Rosalind and Wilkins, a colleague. She was able to produce Photo 51, the most famous X-ray image of DNA, and obtaining this image took over 100 hours, and the calculations to analyze this image took over a year. It was reported that Wilkins showed Photo 51 to Watson and Crick without Franklin's knowledge. Using Franklin's data and by fitting the missing pieces to the puzzle, Watson and Crick published their model in April 1953. Meanwhile, Franklin finished her calculations, arrived at the same structure, and submitted her results. Yet Franklin's article was published after that of Watson and Crick's, in the same issue of Nature, making it appear that her experiments just confirmed Watson and Crick's breakthrough instead of inspiring it. Unfortunately, Rosalind Franklin passed away due to ovarian cancer, and it is said that the radiation she exposed herself to get the X-ray results may have caused it. It is sad to say, in other words, that she died for the discovery that she is hardly credited for. Yet her workings helped in tackling one of the greatest scientific mysteries of the last century. Watson, Crick, and Wilkins won the Nobel Prize in 1962 for their work of DNA. It is said that Rosalind too would have been recognized by Nobel Prize if only it was awarded posthumously. Sadly, she faced injustice as she wasn't recognized for her love towards the mere development of the sciences. She also faced gender discrimination. The unfair treatment in society between different genders is still a prevailing social problem. Yet, we can proudly say that it has reduced to a great extent. Man or woman, at the end of the day, we are human. We are not identical, yet we are equal. I believe that Rosalind Franklin's name should be prominent in the science books of our school students and should be well associated with the great discovery of the structure of DNA. And we should all take a moment to appreciate the void of science she filled with her efforts. It is about time to honor the great Rosalind Elsie Franklin, the unsung mother of DNA.
Thank you, Ms. Hettige. Now I would like to invite our second presenter, Ms. S.S.S. De Silva from the Institute of Chemistry, Ceylon.
A very good morning to all. I am Sachin De Silva, a fourth year student from College of Chemical Sciences, Institute of Chemistry, Ceylon. My essay highlights the life and legacy of Marie Curie, an iconic female chemist that still continues to inspire me and undoubtedly any present female chemist because of her unmatched resilience and curiosity. Her work in radioactivity broke new ground in the fields of chemistry and physics through the discovery of the radioactive elements radium and polonium, essentially changing what was fundamentally known about the atom back then. Her research also pioneered the use of radiation in cancer therapy. The iconic photograph captured during the 1927 Solvay Conference struck me to be ever so intriguing, for among the assembly of celebrated figures in science such as Einstein, Schrödinger, and Heisenberg was Madame Curie, the sole female scientist. Her life achievements continue to offer incalculable inspiration to the present day by being the first woman to win a Nobel Prize, the first person to win 2 Nobel Prizes in different areas of science, the first woman to receive a doctorate in science in France, and the first woman to deliver a lecture at Sorbonne University. And it was all while battling the ruthless misogyny set in her days. Her commitment to science paved the way for the recognition of many more dynamic women scientists to come, in contrast to the uphill battle she pursued in order to earn a seat in the male-dominated scientific community. Marie Curie was more than a revolutionary scientist. She was a devoted wife to Pierre Curie and a loving mother to her 2 daughters, Irene and Eve. Her balance in managing family and career was astounding and remains a pivotal example to many young women scientists today. Her humbleness and simplicity in the face of fame speaks volumes about her character. Einstein has quoted on the quality of her character as being, of all celebrated beings, the only one whom fame has not corrupted. That credited to her generosity as she distributed most of the Nobel Prize money to her students, friends, and family members. Curie's incomparable humility was expressed better through the words of her daughter Irene. In her uncompromising soul, she would have judged herself dishonest if she had kept for one unnecessary moment the money which could now serve as a lifebuoy to another young girl. Curie's unmatched resilience to persist through hardships sets a great example for ambitious women seeking entry into the worlds of science and academia. shoulder to shoulder with their male colleagues. Marie Curie's remains lay rest in the Pantheon in Paris, where many gather to celebrate the woman who broke barriers with the unwavering curiosity for science. May she continue to inspire chemists such as ourselves forevermore. To conclude, I would like to express gratitude to Dr. T. Gobiga, Head of the Department of Chemistry, and Dr. Dinosha Odukala, Senior Lecturer Grade 1 at College of Chemical Sciences, for their support and encouragement. And last but not least, thank you very much to the Women Chemists Committee of the Institute of Chemistry Ceylon for organizing this wonderful essay competition. Thank you very much.
Now I would like to invite our third presenter, Ms. W.R.H. Veerasinghe from University of Kelaniya.
Even though women's contributions to chemistry run back to the age of alchemy, how much of it is acknowledged around the world seems to raise a question mark. Nonetheless, the contributions they have made with or without recognition continue to help the mankind in uncountable means. One such remarkable woman is Gertrude Bell, who shared 1988 Nobel Prize in Physiology or Medicine with George H. Hitchings and Sir James Black. Trudy, as called by her loved ones, was born in 1918 and had an insatiable thirst for knowledge, regardless of the subject. But demise of her beloved grandfather from stomach cancer stimulated her to choose science to find a cure for the deadly disease and to graduate majoring in chemistry. It's impressive how this personal touch in her decision-making resulted in her being a holder of 45 patents of life-changing discoveries. Unfortunately, a sudden family financial crisis hindered her entering graduate school, and her request for a fellowship failed in the male-dominated world. But she bided her time while working in various jobs and finally graduated with a Master of Science degree from New York University while working as a teacher. Finally, when World War II diminished the ranks of male chemists, Elian's perseverance worked in her favor. She joined Dr. George Hitchings at Burroughs Wellcome's research laboratory, intrigued by his work. She got involved in investigating purines and purine analogues as chemotherapeutic agents and reformation of the conventional trial and error method in drug discovery. Her dream of earning a PhD shattered when Brooklyn Polytechnic Institute decided not to let her continue doctoral studies part-time. Nevertheless, Dr. Hitchings accepted Trudy's brilliance without having to complete a doctorate. Their work included breakthrough discoveries with the basis of blocking nucleic acid synthesis in cancer cells and poisonous organisms without damaging the normal human cells. They developed an array of new drugs that were effective against leukemia, autoimmune disorders, urinary tract infections, gout, malaria, and viral herpes. All this work earned her many respectable positions in the scientific society. She was also the first woman to be inducted into the National Inventors Hall of Fame in 1991. Despite her PhD dream getting shattered early, she was later awarded 3 honorary doctorate degrees. However, her true motive was to help the mankind. When inquired whether she was aiming for the Nobel Prize all her life, she said, "What we were aiming at was getting people well, and the satisfaction of that is much greater than any prize you can get." This amazing personality became a motivational factor in inspiring me to enter the world of drug discovery, guided by an equally inspiring woman chemist. Even after passing away in 1999, the trail left behind by this noble Nobel laureate is inspiring many a chemist around the world, while still saving lives from her incredible discoveries. Thank you.
Thank you, Ms. Veerasinghe. Now I would like to invite our fourth presenter, Ms. W.K.D.P.S. Kodituwaku from University of Colombo.
Good morning, everyone. I'm Pooja Kodituwaku. This is the inspiring journey of Professor Ada E. Yarnath. Professor Ada E. Yarnath is an amazing Israeli chemist who was inspired by Marie Curie. Ada Yarnath was born on June 22, 1939 in Jerusalem. Ada lived in cramped quarters in Jerusalem, and her childhood was extremely difficult due to their low income. However, her parents had desired poverty to provide a proper education for their daughter. During her school time, Ada's father died at the age of 42. Despite all the obstacles, Ada did not give up her education and became a strong young lady who could cope with every challenge. After much effort, Ada completed her bachelor's degree in chemistry from the Hebrew University of Jerusalem. She obtained her PhD for X-ray crystallographic studies on the structure of collagen. She began her scientific career by accepting a postdoctoral position at Carnegie Mellon University in 1969. A sudden bicycle accident and a strange thought of a polar bear led to Ada's life-changing discovery. During her recovery time after the bicycle accident, she read an article about hibernating polar bears. After reading this article, she assumed that ribosomes might be packed in an ordered manner for bears to go in and out of hibernation. It's an idea then came up against popular belief at that time. Professor Ada realized that in order to investigate ribosomes, they must first be crystallized. At the time, many scientists were of the opinion that this crystallization process was impossible. Although people started calling her a dreamer, she never stopped researching her unconventional idea. After several failed attempts, she was able to create the first ribosome crystal in 1980. In 2000, Professor Ada and her teams were able to solve this complete spatial structure of bacterial ribosomes. Later, the team discovered a mechanism by which the antibiotics bind to bacterial ribosomes and stop protein production after binding. After many years of hard work, Professor Ada Yonad won the Nobel Prize in Chemistry in 2009 for her discovery of ribosome structure and its functions. Professor Ada received several honors and awards throughout her research career. The scientific research done by Professor Ada Yonad supported the creation of more sophisticated and effective antibiotics. She also provided better pathways to fight the pathogenic protein production, identifying cancer cells. In my opinion, Professor Ada's genuine love towards science and her endless curiosity made her a great scientist. She is an extraordinary person who dedicated to science in spite of praise, fame, and profit. In a world that brags about their educational background, she has shown just how to use them for the goodwill of mankind. People in this world remember us only when we do something impactful for the world. At some point, people will no longer remember Ada Yona's family background, her educational backgrounds, the awards she received, the failures in her life, and much more. But they will well remember one thing. That is her famous discovery of ribosomes, and that is the legacy she's going to leave behind one day. Thank you.
Thank you, Ms. Kodituaku. Now I would like to invite our fifth presenter, Ms. MLF Nusfa from University of California.
Of science is not that recognizable unless she is able to make her own brand. But still, there are great women who have broken that stereotype and achieved fame. Today, I'm here to share you about my most inspiring female chemist, Stephanie Kwolek. She is known to discover Kevlar, a heat-resistant and a strong synthetic fiber used in the development of body armor for police and the military. Walking you through the life of Stephanie Kwolek, she had always wanted to pursue her career in medicine. Thus, she obtained her bachelor's, majoring in chemistry. And in the mission of saving money for her medical school, she was hired by a research company for a research position. Meanwhile, she found out that polymer research to be more challenging and interesting, which made her drop the idea of studying medicine. And in 1960s, there was a high demand for a light-weighted fiber. And in that process, she was able to invent a new polymer. And she was amazed to find out that it was not only stronger than already existing nylon, but also 5 times stronger than steel by weight. And also there was laboratory test proved that the fiber to be fireproof. So this innovative polymer was released commercially under the name of Kevlar, which is used in bulletproof vests, car tires, and many other applications as of now. Her determination and the interest in chemistry has saved thousands of lives over the years, and also it continued to do so even after her death. So this proves us the fact that it is not only the medicine faculty that could save the mankind, and also it taught me to do something beneficial for the mankind. And apart from being a research scientist, she also served as a research consultant and also loved tutoring in chemistry, helping out many young talents across the world with her demonstrations. She has inspired me the most to chase my dream until I'm content and satisfied with my life. And also it reminded me that determination and consistency is the key to success. Thank you.
Thank you, Ms. Nusfa.
Thank you, madam. Now, I would like to cordially invite Professor Suranga Vikramarachi, Coordinator, Photographic Abstract Competition, to announce the winners.
Thank you, Shanti. The winners of the first photographic abstract competition are: third place, Ms. T.W. N.J. Pereira from University of California. Second place goes to Ms. D.D.D.H. Devage from University of California. And the winner is Ms. N.T.M.J. Parnaratna from University of Sri Lanka. Congratulations to all the winners, and I would like to thank all the participants who submitted their photographic abstracts to make this event a success. And also, I would like to take this opportunity to thank Dr. Iveshika and Dr. Masumi for serving as judges of the photographic abstract competition. Thank you very much.
Thank you, madam. Next, I would like to invite Dr. Medha Gunaratna, Coordinator, Essay Competition, to announce the winners. Over to you, madam.
Thank you, Shanali. I will announce the first winner of the essay competition, Miss A.L. Hettige from the Institute of Chemistry, Ceylon. Second place, Miss S.S.S. De Silva from the Institute of Chemistry, Ceylon. Third place goes to Miss W.R.H. Veerasinghe from University of Kelaniya. The fourth place, Miss W.K.D.P.S. Kodituakku from the University of Colombo. Fifth place, Miss M.L.F. Nusfa from the University of Kelaniya. Congratulations to all winners. And I would like to thank all the participants of this event and the judges, Professor S.S. Iqbal and Professor Shayanika Padumadasa for serving as judges in this event. Thank you.
Thank you, madam. To conclude the event, I would like to cordially invite Dr. Dinusha Udukara, Secretary, Women Chemist Committee, to propose the vote of thanks.
Thank you, Shanali. A warm and graceful morning to all of you. It is my proud privilege to propose the vote of thanks on the Sri Lankan Breakfast Event 2022, organized by the Women Chemist Committee of Institute of Chemistry, Ceylon, to coincide with the UPAC Global Women Breakfast Event 2022. It is an honor and pride for us to host this event for the second consecutive year. First, my sincere thanks goes to the President of Institute of Chemistry, Ceylon, Professor Shriyanti Daraniyagala, and Professor Priyani Paranagama, the Chairperson, WCC, for being rock of a support and especially for guiding us throughout the event. I'm very much grateful to Professor Suranga Vikramarachi, the coordinator of Photographic Abstract Competition, and Dr. Medha Gunaratna, the coordinator of the essay competition, for their valuable contribution and efforts in coordinating and organizing the competitions. I would like to extend my sincere thanks to all the committee members and the members of WCC who have given their time and support in organizing the event. Above all, I would like to congratulate all the winners of the photographic abstract and essay competitions and sincerely thank all the participants for accepting our invitation and participating. I may take this opportunity to express my sincere thanks to all other participants who have joined us through Zoom, academic staff, teaching assistants, webinar crew, and all the others who made this event a success. Without your support, we would not have accomplished what we had dreamed for. Last but not the least, a very big thank you to Ms. Shanali, our compeer today, for all what she has done to make this a reality. Finally, I thank all of you for being with us, and I wish you all a pleasant day. Over to you, Shanali.
Thank you, madam. We have organized a traditional Sri Lankan breakfast. Let's enjoy the breakfast now. Thank you, everyone, once again.